Hello guys, today's task is prediction using decision tree algorithm. So in this task we need to create a decision tree classifier on the world famous iris dataset and we have to visualize it graphically. Our goal is to feed the data to this classifier and it should predict the right class accordingly. I know it will not predict 100% but at least we should get around 95+% so that we can say our class prediction is good. So instead of creating a new dataset, I will split the train and test. I'll split the data into train and test so that we will check whether our prediction works correctly or not. So you can easily get iris dataset on the internet. If you are unable to find or if you feel lazy to go to the data search, you can get easily from the sklearn.dataset. So as it is world famous, it will be available easily. So what is decision tree? Decision tree is a non-parametric supervised learning method which is used for classification and regression. So it's like a tree-like graph with nodes and representing the place where we pick an attribute and ask a question. Edges represent answers to the question and the leaves represent actual output or class label. So firstly we have to import all the required libraries for analysis, namely pandas, numpy, matplotlib and zero, and then loading the dataset. So I will get the dataset from the sklearn.datasets. It will be available in the form of an array, as you can see, and all the species names are indexed or replaced by 0, 1, 2 for Setosa, vesicular and virginica respectively, and you can also see the feature names settled with this one. So firstly we have to do analysis on the data frame so that we need to confirm because it is good or it is clean, or we need to perform cleaning again. So for that we can confirm that we can convert the data set into data frame, or you can easily get the data set and create a data frame for it. Here is this one. Here is the creation of data frame, and you can check the head, describe and this info. As you can see from info, there are no null objects, so we can say that our data set is clean as good. So we can go forward with this. Now we can check the relationship between columns of the data set. So if there are few number of columns, the best one is to go for pair plot because it will give the correlation, it will give the relation between each and every column easily. So as there are 4 columns here, we can get 4 by 4, 16 columns. Now we need to find the correlation between the columns. We can find using heat map. So for this one, you can see this correlation. From this we can see that the sepal width and sepal length are mostly correlated or correlated the most. And we can also see how the species is distributed among the box plots, among the columns using box plot. Now we will come to the final task, building the decision tree classifier. So firstly, we need to declare input and target. X equal to iris.data, y equal to iris.target. Now we need to split the data into train and test data so that we can perform our prediction on this. This train, test, split, etc. We fit the decision tree classifier with the train data so that we need to check whether it is perfect or not. You can import decision tree classifier from sklearn.tree and then we need to visualize it. For visualizing we need py.plus and graphics libraries which we can get from the sklearn. Here is the visualization, and now we need to estimate the prediction. So as we split the data into train data and test data, firstly we need to get confirmation that if we predict the algorithm on X train, we need to get it as a Y train. So here I use the prediction algorithm on X train and compared X train, so Y train and Y test one, which I found is perfectly alright, as there is no difference, not even a slight difference I can see in these two. You can check the count plots, you can see the exact numbers, they are accurate. So now it's time for testing. So again, y test2 equal to d3pro.predict of x test. So again, you compare y test2 and actual y test, which we have split the data, and compare them both. So yeah, here you can check. You can see this. There are one can notice, but there will be a slight difference in the test data, as no one can achieve 100% accuracy in the prediction algorithm, as far as I know. So for that one, we need to find the accuracy and confusion matrix. These are some of the metrics which are used to find the accuracy, which are used to find the goodness or correctness of the prediction. So when I find the prediction accuracy, I found it as 96.2 to 64%, which is considered as good one in the most of times. Thank you for taking time to watch this video and ignore for my voice. Thank you.